Welcome to Let's. Today, we embark on an epic journey to unravel the mysteries of our neighboring planet Mars. We would be covering the full story, from ancient myths to modern science, from failed missions to groundbreaking discoveries and future missions. Join us as we delve deep into the red planet's past, present, and future. So let's start the journey. And if you have not subscribed the channel yet, please do and click on that bell icon to get updated for latest video. Let's start with the ancient observations and cultural beliefs of the red planet. To our ancestors, Mars was more than a celestial body. It was a symbol of war, power, and mystery. The Babylonians tracked Mars's motion and associated it with Nergal, their god of war and pestilence. The ancient Egyptians, noting its blood-red color, called it Her-Desher, or the Red One, reflecting its fiery appearance. In Greek and Roman mythology, Mars was personified as Ares and Mars, respectively gods of war, embodying the planet's ominous hue. In India, Mars is known as Mangal or Kuja, a warrior planet believed to bestow strength and courage when favorably placed. Chinese astronomy refers to Mars as the fire star, linked to the element fire in the five phases system. Across cultures and eras, Mars appeared in myth and omen. Its red hue was seen as a harbinger of war and strife. Chinese astrological lore ties the fire star to blood and imperial destiny, while Hindu mythology describes Mars as a powerful but tempestuous warrior god. Even in pre-modern Europe, astrologers warned that Mars's influence could stir tempers in battles. These stories, from Babylonian epics to Egyptian temple records, show humanity gazing up and finding our own fears and hopes reflected in that radish point of light. While these stories sparked wonder, it was the invention of telescopes that shifted myth into science. The true nature of Mars began to emerge in the telescope age. In 1610, Galileo Galilei was the first to turn a telescope on Mars. He saw only a tiny disk, but soon astronomers like Christian Huygens in 1659 were resolving features. Huygens measured Mars's rotation nearly 24 hours and sketched a bright polar cap and a dark region known as Syrtis Major. In 1777, Friedrich Wilhelm Herschel noted two bright polar caps on Mars's tilted axis, deducing that Mars had seasons much like Earth's. In 1877, Asaph Hall discovered Mars's two small moons, Phobos and Deimos, solving a long-standing mystery about satellites. By the 19th century, detailed mapping was underway. Italian astronomer Giovanni Schiaparelli produced one of the first detailed Mars maps in 1888. His map labeled numerous canali, channels, across the planet, which was later mistranslated as canals, igniting speculation about Martian engineers. Percival Lowell fueled this idea, founding an Arizona observatory in 1894 to study these linear features. Lowell wrote publicly that the canali were probably the work of some sort of intelligent beings, reflecting the hope that Mars harbored life. Though later disproven, this idea captivated the public imagination. Despite hopes of a lush Mars, telescopic views remained frustratingly vague. Even the best pre-space age photo of Mars from Matt Wilson in 1956 was a fuzzy orange disk. It hinted only at broad dark regions and a bright polar cap, changing with the seasons, still no concrete evidence of water or life. It took cameras in space to unravel Mars's secrets. Beginning in the 1960s, robotic explorers revolutionized our view of Mars. On July 14, 1965, NASA's Mariner 4 became the first spacecraft to fly by Mars and return close-up images. The pictures showed a cratered moon-like surface, dashing the idea of a teeming Mars. NASA's Mariner 9 in 1971 became the first orbiter of another planet. It mapped 85% of Mars in over 7,000 images, unveiling Olympus Mons and Valles Marineris for the first time. Mariner 9's data identified about 20 volcanoes on Mars, including Olympus Mons, later confirmed as the tallest volcano in the solar system. It also hinted at past water-carved canyons, changing the consensus on Mars's history. The Viking program in 1976 placed 2 landers and orbiters on Mars, returning the first color images of its plains. No conclusive life signs were found, but Viking proved we could safely touch down on Mars. In 1997, NASA's Pathfinder mission delivered the first Mars rover. Sojourner using an innovative airbag landing. Pathfinder found abundant rocks and soils altered by water, reinforcing that Mars once was wetter. In 2004, twin rovers Spirit and Opportunity landed in different hemispheres. Within weeks, Opportunity discovered round hematite. Blueberries, a mineral that forms in water, and Spirit later found evidence of ancient hot springs. These rovers proved beyond doubt that early Mars had liquid water on its surface. The 2010s brought ever more sophisticated explorers. In 2008, NASA's Phoenix lander studied the northern polar soil and found water ice just below the surface, confirming reservoirs of ice. NASA's Curiosity rover, landing in 2012, aimed to assess habitability. Curiosity found fine-grained lakebed sediments and clays, indicating an ancient freshwater lake environment. It even detected complex organic molecules and noted seasonal fluctuations in methane in the atmosphere, sparking debate over a possible biological origin. More recently, Perseverance, landing in 2021, has continued this search. It is collecting rock cores in Jezero, crater for a future Mars sample return, a joint NASA-ESA effort. If all goes as planned, we could bring Martian rocks to Earth in the 2030s. Perseverance also carried the Ingenuity helicopter, which achieved the first powered flight on another planet in April 2021, a technological milestone. Meanwhile, other nations have entered the Mars race. In 2014, India's Mars orbiter mission called Mangalyaan reached orbit on its first try, a remarkable success, and later detected methane and signs of surface change. In July 2020, 3 new missions launched together: China's Tianwen-1, the UAE's Hope orbiter, and NASA's Mars 2020 Perseverance. Hope arrived first on February 9, 2021, becoming the first Arab mission at Mars. Tianwen-1 followed, successfully placing the Zhurong rover on Mars on May 14, 2021, making China the 3rd nation to land there. It is surveying geology and searching for water ice. Not every mission has succeeded. Early efforts often ended in disappointment. NASA's Mariner 3 in 1964 failed to reach Mars, and ambitious probes like Mars Observer in 1992 were lost just before arrival. 2 NASA probes in 1999, the Mars Climate Orbiter and Mars Polar Lander, were also lost on arrival, the former due to a metric unit mistake. International attempts have failed too, like Russia's Mars 96 and the Schiaparelli lander in 2016, but each failure taught engineers lessons, improving reliability for future explorers. When missions do succeed, they often yield groundbreaking discoveries. The Mariner and Viking data shattered the old paradigm of a warm, Earth-like Mars. The twin rovers Spirit and Opportunity rewrote the textbooks by conclusively proving ancient water. Curiosity's findings of lake sediments deepened that understanding. More recently, transient phenomena have surprised scientists. The Curiosity rover has observed mysterious seasonal methane plumes in the atmosphere. NASA's Mars Reconnaissance Orbiter has documented recurring slope linear dark streaks that seasonally ebb and flow on steep slopes initially interpreted as salty liquid flows. Later analysis suggests they may be dry sand flows, but at the time they hinted at present-day liquid water. These discoveries have upended assumptions, showing Mars is still geologically and chemically active in ways we're still striving to understand. But with failure came resilience, and with resilience came the rise of new players and new ambitions. While science advanced, Mars captured the popular imagination. Novels and films have long depicted Martians and red planet adventures. Jules Verne and H.G. Wells famously imagined invading Martians in War of the Worlds, 1898. Edgar Rice Burroughs created a sword and sorcery Barsoom in A Princess of Mars, 1912. Ray Bradbury's The Martian Chronicles, 1950, set human colonists amid poetic tragedy on Mars. More recently, Andy Weir's The Martian, 2011, dramatized survival on a deserted Mars. Each story reflects its era's hopes and fears, from Victorian wars to Cold War anxieties to modern colonization dreams. Mars also figures in modern conspiracy and ancient astronaut lore. The famous face on Mars in Cydonia, seen in a 1976 Viking image, sparked theories of a buried civilization, though higher resolution images later showed it to be a natural mesa. Fringe authors speculated about ancient Martian cities or NASA cover-ups of life detection. Even today, persistent rumors with no scientific basis claim that NASA is hiding evidence of Martian life or artifacts. While mainstream science finds no proof of past civilizations, these legends underscore our enduring fascination with Mars as a mirror of our own stories. Yet, as sci-fi expanded our imagination, real-world scientists were already designing the future of humans living on Mars. As we stand on the cusp of a new era in space exploration, Mars beckons as the next frontier. The red planet, once a distant point of light in our ancestors' sky, is now the focal point of ambitious plans by space agencies and private enterprises alike. Let's dive into the future missions aimed at Mars and the visionary plans to establish human settlements on its surface. NASA's roadmap for Mars exploration is both ambitious and methodical. The agency's Mars Exploration Program outlines a series of missions designed to deepen our understanding of the planet's geology, climate, and potential for life. These missions aim to pave the way for human exploration by the 2030s. One of the key initiatives is the Mars Sample Return Campaign, a collaborative effort between NASA and the European Space Agency. The goal is to collect samples from the Martian surface and return them to Earth for detailed analysis. This mission is crucial for understanding the planet's history and assessing its. In addition to MSR, NASA is planning the Mars Ice Mapper mission, which aims to locate subsurface ice deposits. Identifying these resources is essential for future human missions, as they could provide water for drinking, oxygen production, and fuel. Private companies are also making significant strides. SpaceX, under the leadership of Elon Musk, is developing the Starship spacecraft, designed for long-duration missions and capable of carrying large crews and cargo to Mars. The company envisions launching its first crewed mission to Mars in the late 2020s or early 2030s. Establishing a human presence on Mars presents numerous challenges, from the planet's harsh environment to the psychological effects of isolation. However, researchers and engineers are developing innovative solutions to address these issues. Radiation exposure is a significant concern on Mars due to its thin atmosphere and lack of a magnetic field. To mitigate this, habitats may be built underground or shielded with materials like regolith. Advancements in habitat design are focusing on creating safe and sustainable living spaces for astronauts. Life support systems are being designed to recycle air and water, reducing the need for resupply missions from Earth. In situ, resource utilization technologies aim to extract water from the Martian soil and produce oxygen and fuel, making long-term habitation feasible. Food production is another critical aspect. Researchers are exploring hydroponic and aeroponic systems to grow crops in controlled environments. These systems would provide fresh food and contribute to life support by recycling carbon dioxide and producing oxygen. Addressing the psychological well-being of Mars inhabitants is equally important. Isolation, confinement, and distance from Earth can impact mental health. Strategies such as virtual reality environments, regular communication with Earth, and structured routines are being considered to support astronauts' mental health. Elon Musk's vision for Mars extends beyond exploration. He envisions a self-sustaining city on the planet. SpaceX's Starship is central to this plan, designed to transport large numbers of people and cargo to Mars. Musk's goal is to establish a colony with a population of 1 million people, making humanity a multi-planetary species. To support this vision, Musk has initiated projects like Starbase in Texas, a launch site for Starship, and a prototype for future Martian settlements. The development of Starbase demonstrates the integration of infrastructure, technology, and community planning necessary for Mars colonization. Musk emphasizes the importance of making life multi-planetary to ensure the survival of humanity. He argues that establishing a presence on Mars could safeguard human civilization in the event of catastrophic events on Earth. The journey to Mars is not a solitary endeavor. International cooperation and private sector involvement are crucial for the success of Mars missions. Agencies like ESA, JAXA, and Roscosmos are collaborating with NASA on various projects, sharing expertise and resources. Private companies, including SpaceX, Blue Origin, and others, are contributing innovative technologies and commercial approaches to space exploration. These collaborations are accelerating progress and reducing costs, bringing Mars within reach. As we plan for human settlement on Mars, ethical and societal considerations come to the forefront. Questions about planetary protection, the rights of settlers, and the governance of Martian communities need to be addressed. Planetary protection protocols aim to prevent biological contamination of Mars and Earth. Ensuring that human activities do not harm potential Martian ecosystems is a priority for scientists and policymakers. Governance of Martian settlements raises questions about laws, regulations, and the rights of inhabitants. Developing frameworks for self-governance, property rights, and conflict resolution will be essential for sustainable communities. The path to Mars is filled with challenges, but the progress made thus far is promising. With continued innovation, collaboration, and determination, the dream of setting foot on Mars and establishing a human presence is becoming a tangible goal. As we look to the future, Mars stands as a testament to human curiosity and the relentless pursuit of exploration. The red planet, once a symbol of war and mystery, may soon become a new home for humanity, marking a new chapter in our cosmic journey. In the end, Mars has taught us humility and wonder. Ancient sages saw in it omens. The scientific age revealed a barren desert. Today, we glimpse a more nuanced story of a once hospitable world. The red planet continues to excite our curiosity as object of rigorous science, inspiration for dreams of human exploration, and canvas for the stories we tell about life in the cosmos.